Hello and welcome to this video from libreprogramming.org, and as I have said in my third video of data structure and algorithms, that we will discuss appending, searching and counting in this particular part. So we have seen this, so let's skip to appending at the end. Now appending at the end is very simple. So what is passed is the head pointer. Why I have passed it as pointer to point trace? Because if there are 0 elements, then it will become the head, and then we need to modify the head. So that's why we need a pointer to pointer, so as we can modify the address of the head pointer. Now this is a very straightforward code, so I have not even drawn the diagram. So we just scan the number, and this is the number which is our data portion I, and we malloc a temporary node and we assign the I to its data portion, and next is null. Now remember, the last node's next will always be null. Now if count of head is 0, that is there are no nodes, then we simply make head to point to temp. And if there are nodes, that is if this is not equal to 0, and I have a return here. See, it's a void function, but still we return from here, because if this happens, no point going forward, right? Now, if there are elements, that is if this is not equal to 0, then we iterate till head next is not equal to null. Remember, this is not plain head, this is a pointer to pointer, so we need to write using star head, and then we invoke the member of operator, that is arrow operator, and then we iterate. And when we hit the null, that is head next becomes null, then we simply say head next is equal to temp, because temp next is anyway null, right? Head next was null before this, because we will hit null here in this while loop. So this is a very simple code, and that's how you append. Now if you look at the complexity of this function, then that is also very simple. It will always have order n complexity. Why? Because if there are n elements, then you have to scan till n elements in this loop, right? Because those many head is equal to head next you have to do, and there is no space here. Okay, so this is just plain error. Okay, so now we proceed to counting number of nodes in linked list. This is also very easy. So again, I have not drawn the diagram. We just move forward using head is equal to head next till we hit head next as null. So I initialize count is equal to 1. Now if head is null, then we say number of elements in linked list is 0, and we return 0. Now we say head, if head next is not equal to null. Now what can happen is head next is not null, right? But here head is null, but in between head next can be null, and that moment if head next is null, then count plus plus will not happen, and that is why I have initialized count to 1. And then we proceed to head is equal to head next. Now suppose we have 2 elements, so head next will not be equal to null, but in the second iteration head next is going to be null, because then head would be pointing at the second element. But in that case, after one iteration, count would become 2. So that's why you need to initialize count is equal to 1. You can alternatively write logic as well. You can initialize it to 0, and you can increment at other places here, or you can return count plus 1 also. So if you initialize with 0, then you need to return count plus 1. Okay, so now we proceed to searching. Now search is also very easy. So while head is not equal to null, if there are elements and we check, then it is at %ds position. Now look at this position variable. Position is 1, right? So why I have initialized position with 1? Because now I am assuming my count of nodes starts from 1. So first node is position 1, second node is position 2, and so on. So if this does not match, then we move on to head is equal to head next. And then we increment the position counter, because then we have a chance to find the value on second. And if it is not found, then we don't print anything. Alternatively, you can make its return type int, and you can return position. but then you will have to initialize position with a non positive value, that is a negative value rather, I should say. You will have to initialize position with a negative value, and then you will have to adjust this in your code. Now, regarding the complexity of counting of number of nodes is also order n, because you will be treating the entire list. But search is a little bit different, because search may be order 1, because you may hit your search at the first node, or it may be order n also. So at an average it will be order n by 2, but in the worst case it's order n. Order n by 2 is also order n, because half really does not matter, because we can take our constant m, if you remember from first video. So the order of complexity in big O notation for search is big O and n for a linked list, singly linked list. So we are done with the complexity of all three, and then I think this is time to terminate this video, and in our next video we will simply breeze through delete and a demo of linked list, and I'll show the code. So this video will also be live on Kunjika, and it will have its own appropriate title. Thanks for watching the video. Happy programming.